All right, let's get started. Thank you so much for joining and welcome to this session on how to do code reviews. I would like to start out with a short story, some experience I had with a code review. So in one of my previous projects, one of my colleagues was working on a library upgrade. It was a major version library upgrade, so there were some backwards incompatibilities. So he had, I don't know, of course, upgrade the version, but also change some code to get the thing working. So it was halfway December. A lot of people were taking days off, taking holidays. So it was really like a nice time to work on such a version upgrade. Not too much distractions you can work on. And I was also on holiday. And when I came back, this colleague posted the he has created a pull request, and he posted the link to the pull request, the code review. He posted on Slack. And when I opened the code review, I saw a div which was like this. This is not something I made up. Those are the real numbers. So as you can see, there were more like 6,000 lines changed, a couple of thousand lines added, lines deleted. It was really like a lot. So I asked him, can you please split up this pull request, because it's way too big to handle in one go. But it turned out that he did more than only the version upgrade, because he needed to adjust the code to call the other API. While he was at it, he also changed some code style rules which were like annoying him all the time, so he included that in the pull request as well. The test had to be changed, of course, because of that new API. But he also restructured the test, so basically everything was changed. So I asked him, can we split it up? But the answer was no, we cannot really split it up. It's too tangled. It's hard to do. So then I had like roughly two options. One was saying, looks good to me. LGTM, approve, and move on. But that didn't feel very professional. So I chose the second option, which took me some time, because so much lines of code changed and test setups changed, really a lot of changes. So I bit the bullet and worked through the whole pull request. So basically line by line, I saw almost every line, I think, but it took some time. It took me roughly 2 weeks to review, and that was of course not only looking at the code, but also discussing, asking questions, clarifications and such. But after 2 weeks, so I think he worked on the pull request or the code for 4 weeks, and then an additional 2 weeks for the review, and then it finally got merged. Of course, that's not the most pleasant experience with pull requests. So I thought, okay, let's dive into some best practices around the code reviews. And yet, here we are. But first, if you have some questions, I would like to answer the questions at the end, if possible, but you can already put them in via the Slido app. So here's the QR code, and if you want to type the link, which I wouldn't recommend, you can use this. I will show the QR code at the end as well. And it's room 6. So, a few things about myself. I'm a software engineer with over 20 years experience, mostly with Java, also did some Scala, and currently I employed as a consultant for SDB Professionals, which is a consultancy company based in the Netherlands. And maybe also nice to add is, when I started out as a software engineer, I started working on code on a Windows shared drive. So back then we didn't have to deal with code reviews. It was just you put in the code and it was there. It was not immediately live. You had to do FTP, but there was no like code reviews. And now 20 years later, I think it's pretty standard to do code reviews on GitHub, GitLab and all those platforms. So we're talking about code reviews, but let's first dive into what it is. So there are multiple definitions on the web. So a code review is some code that someone, a requester, requests to be reviewed by a peer or a reviewer before merging it into the main code repository. Yeah, there's I think almost everyone can agree that this is kind of what a code review is. But there's a lot of, there could be a lot more to it than just this. And if you Google for definitions, you might find others as well. Important to note that it's typically an asynchronous activity. There could be some synchronous part, but it's typically you ask for a review, someone does the review, stuff gets back, and then yeah, that's all asynchronous. And typically it's at least one round. If you get an approval, it could be multiple rounds if there are suggestions to be applied. Typically until the code is approved and merged, and in some cases closed and abandoned because not interested anymore, not interesting anymore. So some, I guess most of who's familiar with code reviews? I think almost everyone. And maybe some people asleep, but indeed, basically everyone. And then you might also know these patterns. I've seen them on previous projects. So one thing is a small PR. Oh, let's see. I'll need to zoom in a little bit. Ooh, there's quite a delay. So it's a small pull request. It's like 2 lines added, 9 lines removed. And it's a documentation change. But what could happen is that you that you get this. This is the pull request, then in the pull request overview, and then you get like 5 comments on a documentation change, really like 5 discussions, could be, but just a few lines and then 5 comments. I think this is a pattern that happens a lot for a small pull request. But if there are like bigger pull requests, which is another pattern you might recognize, big one, not as big as the one I initially showed, but still a big one, then you might get like looks good to me, and it gets approved. So LGTM could stand for looks good to me, or literally garbage to me, but then it's probably not approved but rejected. Yeah, so these are like some patterns you might recognize. So if we want to look into how we can improve our code reviews, how we do code reviews, I think it's important to look, of course, look at essentials. And the first thing that I think is essential is the why. Why do we do code reviews? And it could differ per team. You can probably already come up with some ideas about why you want to do code reviews. But the most important thing, in my opinion, is checking maintainability. So how's the code quality? Are the names clear? Is the methods not too long, for example? You can also maybe recognize this picture about code quality. You can count the WTFs. But yeah, that's important. Code quality. Check how the design is. If there might be some guidelines in your organization about where it should be a layered application and how the layers should be called and how they should interact with each other. Also important one is, are there tests? And how good are the tests? Because a lot of times I see, okay, there are tests, but the quality is not that great, while the tests are there actually to help you. So that's also, I think, a key point to do in the code reviews, that you really pay attention to tests. And the final one in the maintainability part is the documentation. That's probably not our favorite part of the job, but I think if you agreed as a team that you do documentation, then you should also check that in the pull request. And it also helps you get an understanding of what the code review, the new code is about. So this is one of the reasons why you should do code reviews. Another one, which is also an important one, probably evenly, same importance, is knowledge sharing. Because you created something and the other one doesn't know about it, so it's about the code itself, you share that knowledge, so it's a shared responsibility of the code base. But you can also learn coding things, like, hey, I didn't know about this method, or I didn't know that I could use these streams in Java and do this and this and this. It could work both ways. As a reviewer, you could see something, say, hey, I didn't know this. Or you could give it as a comment saying, hey, instead of a for loop, you could use a stream with a map or whatever you want to say. So it works both ways in terms of learning. It improves the domain knowledge because you see the new features, the new requirements coming in, and you get a bigger picture of how the domain is. And as I said, it works both ways. And sometimes you learn some clever tricks from a library or some nice things with code style. And of course, this is the thing that most people think of first if they do a code review. It's finding issues, which is also important, but you probably won't find everything. But yeah, at least you can give it a go. It's important to check, did we build the right thing? Because sometimes there's just like a story and you build something, but yeah, is it really matching the story? Is it matching the requirements of the story? Is it any useful? And of course, did we build it right? So you check for bugs. And a nice pattern here is that typically you're quite good at finding someone else's bugs. So that's the good thing, I think, about a code review, that you're really like determined, okay, I'll find a bug in this one. But that could also be on the security or on the performance aspects. So that was starting with why we do code reviews. So that's, I think, the first thing that you need to determine. Why do we do those? You agree that in your team. Another one is social aspects. So in one of my projects, I was working together with a couple of colleagues, and I had done a couple of code reviews for the same developer. And at some point I said, okay, I'm almost done with my code review. And then she said, oh no, there he is again with his red pen. So I failed to notice that I was only like pointing out what was wrong. I didn't pay attention to. She put a lot of effort in that code. She probably already investigated all kind of paths and alternatives. I was just pointing out, this is wrong, this could be improved. It was not that I was purposely doing that. It was with best intent, of course. But yeah, I didn't pay attention on how it could feel. So it's really good to think about how things come across. Yeah, so some hints what we can do as a requester. If you request a code review, what could you think about when thinking about social aspects? The first thing, it's hard. Be open to feedback. Being open to feedback is not really that hard, but realizing that the comments are about the code and not about you might sometimes be a bit hard, especially if you came up with a clever solution. You're really kind of proud of it. It's like your baby, and then someone says, this doesn't work. And then it's sometimes a bit hard to think, okay, it's about the code. It's not like an assault on me. And it could also happen that things are unclear because someone types it in a comment field in a pull request. And yeah, some information gets lost in that translation to text. So when unclear, discuss things synchronously. Call them up via Teams or walk to the desk and ask what they meant with that comment. But there are also hints for the reviewer, of course. The first thing is be polite. That's, I think, quite easy, but in the heat of the moment you can forget about it. But the easiest thing is to use the word we instead of you. You wrote this code, or you should do this. And you combine that with the request instead of demand. So you can say, okay, should we rename this to, or should we use this library XYZ here? Then it feels more like a team effort and you don't come across that rude. And what I also try to do sometimes is to give praise in a pull request. So if someone found a clever solution, I'll type a comment saying, hey, nice solution, didn't think about it. But it's maybe good to realize that in some systems, this praise can count as like discussions. So if you have the policy of you have to close all discussions, and then you said 10 times like, this is good, this is a great idea, this is a nice solution, then this person needs to check and resolve basically every discussion. So you can also give that praise via Slack or in person saying, hey, there was like a nice find or something. Good to be aware of. And of course, if you give comments, be constructive. Provide ready-to-apply suggestions. So it's easy to say this is wrong, but if you say, hey, if you try it in this way, or if you use that method, then it will probably be a bit easier. and it helps if you try it out yourself. So, then I don't mean try it out and commit, but try it out, see whether it works, and then give that as a suggestion. Because if you immediately commit it, it depends on the team, but typically you eliminate that learning possibility for the other one. And where applicable, try to link to reference material. So that's typically if you use some new parts of a library, of a framework, then it's nice to point to the documentation so that you really have that learning experience also for the requester side. And another one, which is really important, is respect the scope. I've seen a lot of times that there was a pull request and then the comment is like, hey, I don't like this method. And then that method is very close to the code where it was, but not really like the method. Hey, should we extract this to, I don't know, using some subclassing or those kind of things. It's good that you notice it, that it's the case, but I would typically not request to change that in that pull request. So it helps if you say, okay, sounds like a nice opportunity to introduce this and this. Can we do that in a separate PR? And then you can have the discussion there. It's not like a black and white decision in this case. It's not always the case, but it's good to pay attention to. So now we looked at the why for code reviews and the social aspect of code reviews. I think it's also important to have a look at automation because we don't want to do the boring parts, like, of course, compilation. We already do that on CI, right? That's the easy one. Tests, I think a lot of people also run the tests, but it's a bit annoying if you do a code review and then finding out that the tests don't run. That's like wasted time. And it's also, those should be automated. It typically should not be the case that you have to check out the code, run the test yourself in order to do the review. And the same holds for the coverage check. So there are tools that do it automatically for you. So I know before, like years ago, I also did this, and then I run the test with coverage before, and then checked out the new code and run the code with coverage again. And then so I said, oh, okay, the coverage dropped. But yeah, that's something you can really automate, and I think you should. And the same holds for the code style check. So I think one of my rules around code style is I really don't want to see comments about code style. If it can be automated, then I prefer to seeing a PR which creates the new code style rule, and then you can discuss it there, and it also applies it there. So my main point is no comments on things which could be automated easily, and then of course the easily is bit up for debate, but yeah, I think it really helps if you can do all those automated checks. You don't have to do them manually. You can focus on other things. So then a short, I don't know, recipe on at least how I do the code reviews. Typically, I go from high level to low level. First is, why is the change there? Why do you want to change something? What's the pull request about? So I check links to code, a Jira board, for example, read up the user story, try to understand what should be going on, and then I read the pull request description. Does it match my expectation? Do a quick scan of the code, which files are changed, does it make sense combined with the knowledge which I have about the context. And then next step, read the tests and see whether it all checks out, because I have an assumption about what the story is. I saw the code that has been changed, and then in the test check to see whether it really does what I expect it to be. And then when you do it that way, then you also notice it when tests aren't clear enough, because otherwise what I see a lot is that people review the code and then they say, okay, there's 1, 2, 3, yes, we have 5 tests for this, it should be good, and then they don't really read the tests. But I think the tests tell a story, and they should properly express the intent of the functionality. And after I've done that, I work through the code, not necessarily line by line. So typically I'm jumping around through the code, and sometimes it just works better if you check out the code and try it out locally in your IDE. And maybe it's also nice. There was a session this morning about read code. was a session by Marit van Dijk, which was a nice a session, which might be helpful for this final part, work through code. I think that's where that could really be helpful. And maybe good to think about, especially when you're new to a project or part of the project. Then of course you check it out, but then I think it's also nice to play around with the code. So you try to maybe break things, see how things work, run it through the debugger, because this is really like a big learning opportunity. You get to know that code better. But it's probably a good idea to let the requester know, hey, I'm in the like learning mode. Yeah, it could take some time, so maybe it's a good idea that someone else also does a review, especially if you're in a hurry with this this code review. So these are kind of like the basics that I see for or the essentials that I see for code reviews. So I have some additional tips which make the experience a bit better. First one, prepare your pull request. I've seen this go wrong many times. Someone created a pull request and then you clicked on the pull request which they put on Slack, for example, and then, okay, it doesn't compile or CI fails, or, oh, that file shouldn't be there. So do a self-review. Aren't there any unexpected files? Or yeah, it could be that someone checked in a secret or some code from a previous experiment, but you can do that yourself. If you create a pull request for a code review, do a quick self-review. Provide some context, as I mentioned, because that's how I want to start my review, reading the context. So it's good to provide links to context and describe how to try it out is also nice. So there's like a title typically in a pull request and also description. And the description field is big. You can use quite some text there. So you could, so what I've seen on, for example, front-end projects is that they put screenshots from the before and after, or an animated GIF that shows how it works now. So that sometimes help to get into context of what's there. And of course, is CI green? That's the, I would say, the minimum. Or if you request like a preliminary pull request, you can say, okay, CI is not green, but can you still take a look high level? But then you don't want to do a big review because it wastes a lot of time. So prepare, and the second step is promote, because you can create a pull request, but if it's just there, probably no one will pick it up. You can, of course, assign it to someone, depending also on team agreements, whether you just assign it in the GitHub or GitLab. But I think it's useful to also promote it. Let the people know that you assign a pull request to them. Give an indication about the size, because if you say I have 5 lines to review, they probably pick it up pretty quick. And if you say it's like 100 lines, then or 1,000, they might need to reserve some time for that. So I think that helps to plan the pull request. And again, especially if it's like a bug fix, which is important for production right now, give a hint about the context. Say, okay, for this and this story or for this important bug, I created this pull request. So the reviewer can schedule it the right way. Which brings me to the next point, is the planning of the code reviews. Typically, there's no need to drop everything, but I think it's nice to pick it up next. So if you finished, as a reviewer, if you finished your own task, pick up a code review or two. And then it really helps if you know how big they are and how important they are, like from the previous step. Give an indication. So sometimes I get a pull request and then I say, okay, I'll pick it up after lunch. Then people can set their expectations, can pick up a small task and then expect a review back, for example. But don't let them wait too long, don't let them wait like days, or for sure not weeks. And when something is unclear, reach out to the requester, or so if you're reviewing and it's completely unclear, you can of course type a comment, but it's typically, if possible, probably more efficient to reach out and have a chat. And that goes both ways. If you post a comment and it's unclear, then the requester can also ask for clarification. So these were some, I don't know, tips and tricks to do a pull request, but we didn't hit the thing in the story that I mentioned at the beginning of this presentation, which is about the size. This is an important one, as you saw. But these, big pull requests can still happen if you follow all the practices I mentioned before. So now let's dive in what we can try to do to prevent it, and also to see what the issue really is with big pull requests. So if you take a look at how a review flow typically goes. So we start with the coding, or it's the one who picks up the story, does the coding, creates a PR, and there's some time in between, which I called pickup time in this case. At some point the review starts, review goes on, and at the end there's probably some comments and some back and forth. Then the PR gets merged, and then you can deploy or make a release, but then it continues. But what happens with the large pull request is that the coding part takes longer, because there's more code. So it takes, like, instead of like 1 day of coding, there's like 2 weeks of coding in there. So that takes longer. The pickup time typically takes longer, because people know that there's a lot of code to review, so they don't pick it up right away. They schedule it for, I don't know, lazy Friday, or the day that they don't have meetings. What I also forgot in the coding part, if you add a lot of code, there are probably some more conflicts which you need to resolve, and if it takes longer you need to resolve it again, or more conflicts. So there's also more conflicts with other branches, or at least potentially. So when the pull request is picked up and the review started, there are probably more comments. Not always, but typically if there's a lot of code, there's probably a lot to discuss. And what also happens is there's like more context switches. And what I mean by that, if there's like a small pull request and you review it, you can review it in, let's say, 1 session. Like you pick it up after lunch, 15 minutes later or 1 hour later, you're done. So then you were in that same context, and then it's okay, that pull request is done. But with those large pull requests, it could like take hours, so from lunch till end of day, and then next day. But then you probably also do other work, so then there are more context switches also during the review, so that makes it also less efficient. And the nasty thing with these large pull requests is that typically it could be self-reinforcing, because it's a bit small. How do I zoom in? Okay, I'll change the picture. Oh, there we are. So there's oh man, there's such a delay. You can't see the delay. But there's so it's all about cycle time. So if the cycle time gets larger of those large pull requests, what people tend to do is, okay, because it takes long, I'll add a bit more code, because otherwise I need to wait again for 4 weeks. But then you're increasing the problem, because you keep on adding code. So that's good to have in the back of your mind. So one solution is like, looks good to me. So then you still have the large pickup time, but then you have the review, and almost immediately you say, okay, looks good to me, buy and approve. And of course this could happen, right? If you have like code style changes, then you typically know it's all automated. Then it's like big, but it's conceptually like one change. You only change basically the code style rule, and all the rest you trust that it's automated. Or you can do that in a pair. If there's a trust issue, you can, we sit together behind a laptop, we do the change, and then I'll approve it afterwards. But the looks good to me solution is not the best one. Of course, the solution is keep them small, but that requires some skill. The advantage of keeping them small is like quick to review, less the context switching, as I mentioned before, less merge conflict, but it also makes it easier to get started on picking up a pull request, because it doesn't seem that intimidating. And it also keeps the energy high. So if you like finish a pull request after 2 days of review, or you can review 5 PRs in 2 days, that feels more like, okay, we finish things, we get things moving, we get things like to production, or at least to the main branch. and it helps if you keep them focused. So if there's like a bigger refactor, try to do it in a separate PR. It's easier said than done, but I think it requires some refactor skills because you need to kind of recognize it beforehand that you probably need that refactor. Or otherwise you need to have the discipline, if you're working on that story, see that you need a refactor, start a new branch, do the refactor in that branch, and then create a pull request for that one. The advantage of that last thing is that you have the refactor done, and all your colleagues can also profit from that refactor. So if there's so you can profit in the refactor because it gets merged to main, and then you get it back in your code line, but all the others can also use that refactor if necessary. And also code style changes, as I mentioned before, those should be in a separate pull request. Yeah, so it should be conceptually small things. So the ideal situation is, okay, some coding, PR, little bit of pickup time, I don't know, half an hour, a day, depends on the team, of course. Also small is like relative. Review started, merged, and deployed. That would be ideal. So there are some, so it's not always possible, so there are some workarounds you can do. The first one is draft pull requests. So sometimes you recognize, okay, this is really big, we cannot split it up. You know that beforehand, or it's very hard. Then it's probably good to quickly like sketch out a solution and create a draft pull request. So then you, I don't know, for example, you create some controllers, you don't implement the business logic yet, or just high level the business logic with some comments, and then create a draft pull request, ask someone else to review that, because then you'll have like the early feedback. But it's good to mention, hey, please notice this is a draft pull request, so you don't need to go into every detail. It's more about, is it high level the way we should go. And it minimizes rework, because if you finish it into all the details and then someone else comes by and says, hey, okay, this needs to be completely different, yeah, then it's a waste of time. You don't need pull requests for this, right? You can also ask someone, hey, come sit next to my desk, and we'll see how it looks. I think that was what I wanted to say about this one. And there's wait a second. Okay, a second workaround. Another workaround is feature branches. So sometimes if there's really like a big thing, then you create a feature branch and you create pull requests towards that feature branch. So you only have to review those smaller pull requests. So it's not like the big thing that you need to review. At the end, of course, you want to merge the feature branch into your main branch, but then typically you don't do a review that much in depth, because you reviewed all the small parts. So then you typically do the high level overview, final step. The disadvantage is if you do refactorings, then other people cannot use that refactor, because it's on your feature branch. Also, there's not the integration. So if you use something that someone else just removed, yeah, there could be some issues. So but that could be resolved with team communication. If you communicate clearly within the team that you're going to throw away some code, yeah, that might help, of course. But yeah, this could really help. So those were some hints for keeping your pull request small. But no, assume you're doing pull requests for quite a while. At some point, you will find out, okay, we need to improve on our pull request. It's not going optimal, and there's always room for improvement. I think an easy one to start with is check with the team. Are we all on the same page with why we do code reviews? What do we find most valuable? So is it like code style, or do we value maintainability more, or finding bugs? Like I mentioned some of those at the first one of the first slides. But it's good to agree on with your team, because if you're only bug hunting, then yeah, you can skip the discussions on style. It's also good to discuss pull request priority. So okay, do you pick it up right away? So I've been in teams where they said, okay, you cannot pick up a new task until all pull requests were reviewed. There could be an agreement that you have in the team. And of course, have alignment on how you do branches, how you work with feature branches, how you do commits, how you squash, all those kind of things. That also helps because, for example, squashing has an effect on pull request tooling typically. I've also heard about some teams who created like a manifest. So we value smaller PRs over larger PRs. We value this over that. Okay, that could help. Then you put it in a nice way, and you can like the 10 commandments of pull request, or you can come up with such things. But I think the important part is that you're on the same page with the team. There's nothing more annoying than creating a pull request and getting all kind of like detailed comments which you didn't expect because your expectations about pull requests were completely different. And another thing what you can do if you want to improve is use data. I didn't do it that much until I think 2 years ago. I noticed that there's quite some nice features. Like for example, GitLab has merge request analytics. So it shows, for example, how long merge requests were open. So you could use those things to indicate problems. They typically don't give you the solution. They give you insight in what's going on. But it's good to check it regularly, or at least if you suspect problems with pull request, you can check this out. I don't think GitHub has a similar an analytics view on pull request, but I'm not 100% sure because it's a while ago I used GitHub. But at least you can use the data from GitHub. They have an API, and there are some people who created a nice GitHub action from it, and which extracts some data and creates some graphs. So an important one is pull request metrics. So time to review, time to approve, those are numbers that are interesting as you might think about that part of the size. PR size, of course, how much lines were changed. Number of comments is also an interesting one. And sometimes it's also interesting to see that not only the number of comments, but also the number of comments per developer, because there might be some patterns in there, and you might probably know the team members in your team who have like a higher comment count and some who have a lower comment count. Doesn't have to be an issue, but if you think you're all even and it's not, then this will show it. And what type of comments you get, that's also an interesting one. But then you probably need to, I don't know, tag the comment saying, hey, this is a code style comment or architectural comment or bug or whatever. But if you're really interested or have the feeling that something is wrong with the type of comments or it's not in balance, then it might be useful to add some tagging or some way to recognize the comments so that you can plot it out and see what the differences are. And you can also have a look, you could, I'm not saying you should, is the people metrics, like number of open pull requests per person, how big are the pull requests per person, and the number of reviews conducted. That could also help, that you see, okay, that developer does 1 pull request every week and the other one does 10 pull requests every week, or I don't know. Doesn't have to be a problem, but yeah, check whether it matches your expectations. So some inspiration I found on the webs, like this is the number of reviews. Here you see quite an imbalance between the developers. Doesn't have to be a problem, as I said. Oh, I screenshotted my micro break timer. Okay, good. I use a timer. Nasty thing. But here you see a project where they have like tagged their comments. And you can see, let's see. If we zoom in here. Most of the discussions are bugs. Over-engineering, not that much. So that could be a nice thing to look at. And then there's the last one, which is on GitLab, merge request analytics. This is not from one of my projects. Here you see the number of days for a merge request. So 41 days is quite long, but luckily there was only 1 merge request that took like 41 days, but yeah, it's a lot. So those things could help. So, as a final slide, I would say, important things to take away. Start with a why. So, why do you do the merge request or the pull request? But also, in a pull request, start with a why. Why do you create this pull request? Work on team agreements, agree on what you should do, how you approach a pull request. Of course, be respectful, don't forget, even in the heat of the moment. Create small pull requests and keep on improving. That was it. And then we might have some time for some questions. Not sure whether there are already some questions. Let's see. I'll go for... I want a mirror. Yeah, then I can also see the questions. Let's have more popular. How should we distinguish between request for changes versus honest questions? Yeah, I think that depends between request for change, honest questions. Yeah, so that's one of the things. What I mentioned in the story of like, there he comes with a red pen again. I failed to indicate which were like suggestions, questions, and which are like required changes. So I think that for some, I think in GitHub there was a feature that you can indicate that it was like has to change, or at least for the whole PR. But typically I indicated myself. I said, okay, this is a suggestion, you could do it like this, or it's a question. You could agree on some tagging again. So if you want to have some tagging metrics, you could, I don't know, like square brackets, say question, square brackets, must change, or whatever. You can come up with such a thing. But in the like the default GitLab and GitHub, I don't think there's support for that. But of course, like, yeah, you could post questions there, because then, especially if you have multiple reviewers, then both of you know that the question is there. But if it's like one reviewer, you can also ask it on Slack or something else. Oh, this is a tricky one. How much time is good time to spend on PR review? Yeah, as much as needed, I would say. But yeah, it all depends on the agreements, right? If you have like, okay, I'm working for a bank and there shouldn't be any bug because it has to be up 24/7. So then you go the extra mile, trying to find all the bugs, performance implications. You test all those things, which you can also test automated. Yeah, so I've worked on PRs with like 5 minutes. Those are like really small. And it also depends on how much you know about the project. How much context do you already have, or do you need to dive in and try to get an understanding? So it's hard to come up with a good time. Asking for a friend. Okay, Jeff, that's interesting. How to approach large PRs that deal with unknown, complex part of the code base that we understand very little of. Yeah, it depends. If there's, I assume that there are people in the team that know how it works. Then it's probably, so if you find this, that there's like an unknown or a very complex part, then it's probably better to do like a knowledge transfer session if there are multiple people having that same question, or just get a one-on-one and get an introduction about the higher setup first. Because typically I don't try to comment if I don't understand, or I say, okay, I don't know anything about this, but okay, why do we do this and this? So then you give a hint. Okay, it could be stupid question. I'm not sure, and then that should lead, I would say, to a discussion about that someone explains how it all fits together. How we're doing with time? I think 1 more minute, so maybe we can. Okay. Like pair programming, what are the pros and cons of doing pair reviewing? For pair reviewing, do you mean, I'm not sure, it's anonymous. Oh, you want to stay anonymous, of course. That depends. So do you mean together with the one who requested the code review? yeah, yeah, of course it could take a bit more time. So it depends again. Yeah, of course it depends. I think it could be very useful if you're like on different skill levels, for example, or different experience in the domain. Then it could, I think it could pay out. And specifically, if we think about the question from Jeff we saw before, then I think if there are multiple team members who find it difficult to understand or find it a complex part, then I think it could be really helpful to do like pair reviewing, mob reviewing. And could be that in the end, yeah, I think then it could pay off to do it. So specifically for learning, but in some cases there's also like a requirement that 2 people need to approve. But if then that's the case, like if it's like for security's sake, then I would say do it separate, because otherwise you're like in the same tunnel. You're going along in the same direction, then you miss out on other stuff. All right, I think it's time. Yeah. So we had the questions. So if you have more questions, you can find me somewhere around on the conference. I will be here for the rest of the day and tomorrow. And otherwise you can ping me on Twitter or Mastodon or LinkedIn. Okay, thank you.